Okay, so yesterday, well, in the previous video, we talked about completing the square, and all of our a values were 1. There's two different kinds of problems that we might see when a is greater than 1 or a is not equal to 1. This is the first kind. So first of all, something that kind of may not be clear, completing the square is a factoring process. Okay, so completing the square is a factoring type of solution. And when we factor, what is the first thing we always look for when we factor? When we factor, the first thing we always look for should be the greatest common factor. Now, previously when we factored, we looked over at this part, but when we're looking for a greatest common factor now, for completing the square, which is a factoring process, we're going to look for the greatest common factor on both sides. Okay, so when I look at this, what number, well, first of all, they don't have an x in common because this term doesn't have an x. So what number do they all have in common? They all have a 2 in common. So I can divide everything by 2. Now, because this is an equal sign, when I divide everything by 2, it goes away. Okay? So 2x squared divided by 2 becomes x squared. 4x divided by 2 becomes minus 2x. 6 divided by 2 becomes 3. Divided by 2 becomes 3. Now, I have a completing the square problem where a equals 1, and I solve this just like I did yesterday. Okay, so for this one, I would rewrite this as x squared minus 2x plus something equals 3 plus something. So I'm going to look at this and try to figure out what I need to multiply or what I need to add to make this a perfect square. Well, again, if you don't know, b over 2 squared equals ac. b is negative 2 and a is 1. Negative 2 divided by 2 is negative 1. Negative 1 squared. Now remember, when I have a negative 1 squared and negative 1 squared don't give me the same answer. What does mine look like? My negative 2 divided by 2 is negative 1, and it's inside parentheses. I'm squaring negative 1. I'm not taking the negative 1 squared, the opposite of 1 squared. So remember, if it's in parentheses here, I need to put it in parentheses here. This becomes positive 1 equals c. So that means I need to add 1 to both sides. Now again, I did this so I could write this as a perfect square. So I take this and I take the square root. Square root of x squared is x. I take the sign in front of b, and I take the square root of 1, which is 1. So x squared minus 2x plus 1 is x minus 1 squared, and that should equal to 4. Now I have something set up that's a perfect square. I can use the square root method to solve it. So I have x minus 1 equals plus or minus 2. That means x minus 1 equals 2. X minus 1 equals negative 2. Okay, so now I have x equals 3, x equals negative 1, and those are my two solutions. Okay, so this is one problem that you might see. We're going to do the problems in our book at the end, and I'm going to kind of let those be your practice problems. So I'm going to do another problem now. The next problem we're going to do looks a little different, but it's still the same process. Okay, so I have 3x squared plus 6x plus 9 equals 33. What is my greatest common factor here? Okay, hopefully what you said was my GCF is 3, because only these two don't have an x, so I can't divide them by 3. I can't divide them by x, but all of these numbers are divisible by 3. So I'm going to divide everything by 3. Okay, this becomes x squared plus 2x plus 3 equals 11. Okay, now I could subtract 11 from both sides and factor it and find my solutions that way, but the strategy we're practicing is completing the square. So instead, I'm going to subtract 3 from both sides. I get x squared plus 2x equals 9. Okay, now I'm going to rewrite that with my spaces. X squared plus 2x plus something equals 9 plus something. I'm sorry, that should be 8. My bad. Okay, 8. Okay, so 8 plus something. Well, if I look here, and again, y'all are like, why do you keep doing this b over 2 squared equals ac? You're going to know why when I do the next set of problems. Okay? So 2 over 2 squared should equal a, which is 1c. Well, that's 1 squared, 1 equals c. So I'm going to add 1 to both sides of my equation. Okay? So I did that so that I could write this as a perfect square. I take the square root of the first one, square root of the last one, sine from the middle. 8 plus 1 is 9. Now that I have this, it's a perfect square, so I can take the square root of both sides to solve it. Okay, so I have x plus 1 equals 3. X plus 1 equals negative 3. Okay, so when I subtract 1 from both sides, here I get x equals 2. Here I get x equals negative 4. And those are my two solutions. Okay? All right, so those are the first two examples. I want us to try, in our book, I want you to go to the Completing the Square tab, and I want you to try this one right here, the very first one. Okay, so I'm going to give you a minute. I want you to try this, and your response, you're going to be responding to me with your, oh, is this the exact same problem? It sure is. Oh my gosh, you can totally just copy this out of your notes right into there. Okay, so this one we already did. We already know the answer to this one. Okay, so what I want you to do now is I want you to copy, I want you to solve this problem. And when you get a chance, copy that one down from the notes. I want you to solve this problem and give me the answer. Okay, so for this one, the first thing that we're going to do is we are going to rewrite this with our space in there. Okay, and then we're going to figure out what we need to add. Okay, so for, I'm going to do b over 2 equals, well, squared, equals ac. So 4 over 2 squared equals 1c. 4 over 2 is 2. 2 squared is 4. That means I'm adding 4 to both sides. So that means this is now x plus 2 squared equals 16. I'm going to take the square root of both sides. I get x plus 2 equals plus or minus 4. So x plus 2 equals 4. X plus 2 equals negative 4. Okay. Sorry about that. I don't know what happened there. Sorry about that. I kind of like had a moment. X plus 2 equals negative 4. So x equals 2, x equals negative 6. Those are my two solutions for this problem. Okay? Why don't you go ahead and try this one here. Okay. For this one here, we're going to do the same thing. Now this one, what's happening here? Look at this, it's minus 9. So like something inside me wants to say this is already a perfect square trinomial, but because this is negative, I know it's not. So I have to add 9 to both sides to make this a perfect square trinomial. Okay? And again, the reason I have to do this is because this is a negative. Remember, for it to be a perfect square trinomial, the quadratic and constant have to be positive. Okay? So for this one, b over 2 6 over 2 squared equals 1c. So that's 9 equals c. So I'm adding 9 to both sides. So that gives me x plus 3 squared equals 18. When I take the square root, I get x plus 3 equals plus or minus the square root of 18. Now remember, there are 3 possible ways I might see this solution. I might see x equals negative 3 plus or minus the square root of 18. I might see x equals negative 3 plus the square root of 18. Let me erase that so that it's clear. Sorry. I might see negative 3 plus the square root of 18. and negative 3 minus the square root of 18, I might see those actually worked out. So negative 3 plus the square root of 18 is 1.24. And negative 3 minus the square root of 18 is negative 7.24. All three of these answers are acceptable and they are equivalent. Okay? All right. I'm going to do 2 more problems with you because these are a little bit different. Okay? And we're probably going to see more of these on tomorrow's practice. Okay? So these 2 look different. So let's take a look at this first one. 9x squared minus 6x equals 11. Okay, so again, this is a factoring process. So my first instinct is to look for a greatest common factor. Well, I have a greatest common factor here. It's 3, but it doesn't work over there. So it's not my greatest common factor. Okay? In order for it to be the greatest common factor, it has to work for everything. And I can't do it if it doesn't work on both sides of the equal sign when I'm using completing the square. So I have to leave this as it lies. So I'm going to rewrite this 9x squared minus 6x plus blank equals 11 plus blank. Okay? This is why b over 2 squared equals ac is important. Okay? So let's look now. To figure out what we add, we take b over 2 squared equals ac. Well, b is negative 6 over 2 squared equals a is 9c. Aha! Okay, so negative 6 over 2 is negative 3. Negative 3 squared is 9 equals 9c. When I divide both sides by 9, I get 1 equals c. So I have to add 1 to both sides. Okay? This is why we've been doing b over 2 squared equals ac, b over 2, because we're not always going to have a 1 for our a value. Okay? I'm going to do another example like this. Okay? So let's take a look. I'm going to rewrite this as a square. Okay? I take the square root of the first term, which is 3x, the sign from the second one, which is minus, the square root of the third one. So this is 3x minus 1 squared equals 12. Okay? So when I take the square root of both sides, I have 3x minus 1 equals plus or minus the square root of 12. I add 1 to both sides. I have 3x equals 1 plus or minus the square root of 12. I divide both sides by 3. I get x equals 1 plus or minus the square root of 12 over 3. That's the first way I might see it. I might also see 1 plus the square root of 12 over 3 and 1 minus the square root of 12 over 3. And then I might see whatever those are put into my calculator. So I'm going to make a fraction, alpha y equals 1 plus square root of 12 divided by 3 is 1.49. I might also see 1 minus the square root of 12, over 3, which is negative 0.82. Oopsie. All three of these are valid solutions that you might see. We will do more problems like this one tomorrow. Let me do one more example for you. You know what? I'm not going to do one more example for you. I'm just going to do that one. We'll do a bunch more examples in class tomorrow.